For the wrath of God is revealed from heaven against all ungodliness and unrighteousness of men who by their unrighteousness suppress the truth. Yes, I want you to remember those three words especially. They suppress the truth. They push it down. They push it away. They try to hide it, try to cover it up. They don't want people to see it. They don't want to see it themselves. They suppress the truth. This last time we did this one. For what can be known about God is clear, obvious, evident, plain to them because God has what? Shown. What can be known about God is plain to them. God's shown it to them. God's made it clear. God's made it clear. Now the next verse explains this. I don't know if you've ever heard anybody say this or not, but people, it's good to have Bible commentaries, which is where men have preached or written about what they believe a passage means. And so we get to read it. A lot of times they've written down preachers' sermons and things. We get to read it and we get to learn more about it that way. And I heard somebody say one time the best commentary on the Bible is the Bible itself. The Bible is a good commentator on itself. In other words, when you read a verse, you can't figure it out. Sometimes you can find something in another part of the Bible that will help you figure it out. For what can be known about God is plain to them because God's shown it to them. We talked about that last time, which means what? Well, he's going to tell us in the next verse. Okay, that's the best Bible commentary on the Bible is the Bible itself. Here we go in the next verse. It's long. For his something attributes. This means you can't see him. Invisible. For his invisible attributes. God's spirit, you can't see him with your physical eyes, right? He's invisible. But his invisible attributes, namely this is one of his attributes. This means forever and ever and ever. It's eternal. It could be everlasting, but it's eternal. Eternal. Now, and God, no, power is the word this time. His eternal power. God has eternal power. He's eternal. He's everlasting. He's God from everlasting past, everlasting future. He just exists forever. And he's powerful. He's created this awesome creation he made. He's powerful. He's eternal power. And this means, you may not use this word much, but it really means God himself. It's another word for God. Only it's an adjective. No. The second word is what somebody's like. No, they're, no, what you say, what's the characteristics of this person? Well, sometimes we use this word to talk about creation. We call it any, what do we call it? Some people, wait, let me give you one more hint. Sometimes people like to go study creation. Only they say, I'm enjoying nature. There you go. Well, nature means his what he's like. So and this means, I tell you what, you may have heard this. Some people, when they're trying to be very sophisticated, if they taste something, they'll say, "Oh, this tastes." No, no, those words would work, but that's not what I'm looking for. And remember, I said somebody that's very sophisticated. They're kind of, this tastes. It's um, uh, no. It really means like God, but it div divine. There you go, divine. Have you heard anybody say, "Oh, that tastes divine"? To me, that sounds like somebody's just a little bit sophisticated. Oh, that's so divine. Okay, yeah, maybe it's just me. For his invisible attributes, namely his eternal power and divine nature, have been clearly. Now, here's another hard word for you. No, it means it means you it means you can see, you can understand. It's when something's understood or seen. It starts with PER and then C. PERC. Perceive. Have been clearly perceived ever since the something of the world. Yeah, creation of the world in the things that have been made. Now, since that's true, he says, you can see his eternal power. You can see his divine nature very clearly ever since creation of the world and the things that have been made. So therefore, those people who are trying to suppress the truth, they are W.E. What do people try to do when they mess up and they don't want to own it? They try to make a what? Excuse. They don't have an excuse. What's that mean? Don't have any. No, they don't have any. Starts with a W. They don't have any. They don't have an excuse. Wait a minute. Let's think about it for a minute. I'll give you that letter if I need to. Let's think about it. They don't have an excuse. If you have something, oh, there you go. All right. Now you got the words figured out. Let's think about what it means. Okay, stay with me. His invisible attributes, God, you can't see him with your physical eyes, namely his eternal power and divine nature, he's awesome, have been clearly perceived and understood, recognized ever since the creation of the world and the things that have been made. Now, what's he saying? He's saying you can look at what God's made and realize there must be a God. You with me, Trey? You can look at what God's made and realize there must be a God. That's been true. Are you with me? That's been true ever since creation. God created this world, this physical world. He created the sun, moon, and stars. Created us, created animals, birds, fish. Incredible creation. I need to get you with me. And God created us. Thomas, you with me here? Sorry. So God says, I created you with enough sense to look at the rest of my creation and look at yourself and say, wow, there must be a creator. Somebody made this. Somebody made me. Even little kids can recognize that. Little kids don't have any trouble realizing God had to make these things. They just intuitively know it. In Paul's day, when he wrote this, they didn't have microscopes. They didn't have telescopes. They didn't have technology like we have now. But they could look at the stars and the moon and the sun. They could watch a bird flying around. They could look at flowers and say, whoa, it's amazing. They could look at a rabbit running across the road. Calling that little critter. They could look at themselves, their eyes. They think, whoa, whoa, there's an awesome creator to make all this stuff. It was obvious to them. You know why it's not obvious to us today? Because we've been living in a culture with a whole lot of secularists. Not all of them, but the people in the universities and colleges tend to be. And so they've had in our secondary schools, that's one reason you guys are in a Christian school. In a lot of our secondary schools, they completely ignore God. They don't talk about God. They leave God completely out. So there are scientists out there, PhD degrees, lots of degrees. They know lots of vocabulary words. They're kind of arrogant. You know what I mean by that? They think they're smart. And they think, oh, we know stuff you don't know. And if you say, well, it looks to me like God made it, they'll go, no, we're not talking about God. That's religion. We're talking about science. So we're just talking about science here. Leave God out of it. You say, well, how do you think it got here? And they'll say, well, we don't know for sure, but we'll figure it out. We know there's not a God. We're not going to talk about God. That's religion. We're not going to talk about him because they don't believe in God. They don't want to be a God. Now, the truth is God's created a creation that points us to him. We just have to look at it closely and go, wow, there must be a God. That's why he made it. He intended that to be that way. But after many, many years of people going through a school system where they never talk about God and they leave God completely out of it, and they talk about science, they talk about evolution, and they think, well, I guess it got here by evolution, just some little molecules at one time kind of in a little soup, and then little by little, billions and billions of years, and here we are. And yeah, well, and who made the whole thing? They can't, listen, God is now raising up some godly scientists. You may not have ever heard of Michael Behe. I don't know if that name rings a bell with you or not. Behe. He's a brilliant molecular biologist. And he recognizes God. And he knows this couldn't have gotten here. Would you move so I can see Thomas, please? And he knows, thank you. He knows that things couldn't have gotten here without God. He understands it. He's brilliant. He studied these things. He's written books about it. I found out this morning there's some videos that are pretty cool that he's done that I want to see. I haven't had a chance to watch them yet. But God's raising up some molecular biologists. Now, what's the point? The point is, even in Paul's day, they could realize there has to be a creator. Has to be. But in our day, even more so, we look at the molecules of life. DNA has billions of atoms in there arranged just exactly right to carry all the information that a body needs to reproduce itself or to fix itself when it gets cut or to make vision work or to grow from a little single cell in the mother's womb to an adult. All that's in that DNA. These proteins are in there. This protein can't exist without this protein. This protein can't exist without this protein. They had to get there at the same time. They're very complex, thousands and thousands of atoms. And they're arranged just exactly right. There's all these parts. And a little cell is like a little city with billions and trillions and quadrillions even of atoms all doing their work. It's a little factory in there. It's amazing, a little city in there. Incredible. And these guys have studied it. Now, Paul didn't know about that. All he could see was the general creation, still obvious. And now it's even more obvious. And the scientists who look at that and say, nope, we're not going to see God. We're not going to talk about God. We're not going to let God in this. We'll figure it out. They're stupid. God calls them fools. They're suppressing the truth. They're without excuse. That's what he's saying. If and when you get to take the Warriors of Christ class, we talk about this in much more detail, and you learn a lot of awesome things about God's creation. All right. I know this is hard to memorize. I'll help you with it, but let's try. For his invisible attributes, talking about God's invisible attributes, you can't see them. For his invisible attributes, namely his eternal power and divine nature, namely his eternal power and divine nature, namely his eternal power and divine nature, eternal power, divine nature, have been clearly perceived, have been clearly perceived, have been clearly perceived ever since the creation of the world, ever since the creation of the world, ever since the creation of the world, in the things that have been made. They're created in the things that have been made. Ever since the creation of the world, in the things that have been made. So they are without excuse. So they are without excuse. I know it's hard, but let's try. His invisible attributes, namely his eternal power and what? Divine nature, have been clearly perceived in the oh, I'm losing it myself now. For his divine attributes, namely his eternal power and divine nature, have been clearly perceived. It's something in the creation of the world. In the creation of the world, right? Ever since the creation of the world. Ever since. I was forgetting those words myself. I'm sorry. Ever since the creation of the world. I messed that up myself. So his invisible attributes, namely his eternal power and divine nature, have been clearly perceived ever since the creation of the world. And now it's the end. That's where I was getting confused. In the things that have been made. In the things that have been made. In the things that have been made. So that they, did you say it, Madison? Yeah, without excuse. Without excuse. Let's try that one more time, okay? For his invisible attributes, namely his eternal power, divine nature, have been what? Clearly perceived, have been clearly perceived ever since. This is where we messed up a while ago. Ever since the creation of the world, in the what? What? Not, ever since the creation of the world, in the things that have been made. Excuse. Okay. That's a long, hard verse, guys. That's good. I'm impressed. You did really well. All right. We need to pray. Is there anything you want to say before I pray? Okay, ready to pray? Let's pray. Father, thank you so much for your word. Thank you for the Apostle Paul and using him to write these things down for us. Lord, it's amazing how much of this part of your word sounds like 21st century America. So, Lord, help us to take this very, very seriously And Lord, I pray you protect these kids. I pray you protect them. I don't want them to get sucked in by these people who are so arrogant and so blind, and they feel so confident, but they want to leave you out. And Lord, you said they're suppressing the truth and they're without excuse. And you're later in this passage going to call them fools. So Lord, I pray that these kids would not be deceived by those fools, but these kids would realize you are God and you created an awesome creation. And the closer we look at it, the more amazed we are. So Lord, thank you for your awesome creation. And thank you for this passage of scripture. Help us to take you very seriously and to be thrilled and in awe of you. Thank you for being a wonderful Father, a loving Father, a gracious and kind and merciful Father. Thank you for being wise. Thank you for knowing all things. Thank you for being so awesome and powerful. So you get all the glory, Lord, not us. We want you to have the glory. Now, Lord, I want to pray for these kids. I know some of them are struggling with their math, and you know what's behind that. I don't. Some of them may have gotten behind earlier years ago, and they've never ever learned what they needed to learn to catch up, and now they're getting farther behind, and they need to catch up. So I pray you'd help them to find someone, either me at an appropriate time. I don't know when that would be, where I could sit down with them personally and help them with these review sheets, or maybe a parent, or maybe a brother or sister, or maybe another teacher, or maybe a friend that knows what they're doing. I don't know, but Lord, help them to make time to learn this stuff and to study this. So if they made badly on this last test, they can retake it and bring it up. Help them, Lord, to take that seriously, to really be determined to work really, really hard. And Father, I know that we're all different. I know that some of us do math pretty easily and others find math very, very painful and difficult. But Lord, I pray you'd help all of us to do the best work we can with the brains you've given us to learn this stuff. So please help them to take it seriously and learn this as much as possible. Help us to use the time now to learn a little bit more and to, of course, worship you and appreciate you and give you all the glory. We pray in Jesus' name. Amen. All right. I know we're taking up a lot of time. No, I don't think so. They're not going to have chapel then. No. There was somebody. Yeah, there's several things going on there, but anyway. Yeah. Um, by the way, I will remind you again. Um, on the videos, the videos that I do upload, you understand that you can watch the first period's video, right? A lot of times I don't even do this because my microphone will die on me during this class and that kind of stuff. So, but it cover the same material. You understand that. So just watch any of it says seventh grade math. All right. Now this is, let me talk about this just a little bit. You may have done this before. I don't know. But do you want to guess when you have to multiply mixed numbers? This is a mixed number. You want to guess what I'm going to have to do first here? Thank you. That's exactly what you're going to have to do. Now listen, guys, math builds. Math builds. Little by little, it gets more and more complicated. If you haven't noticed, you'll notice it as time goes on. It'll get harder and harder. That's just the way it works. That's why it was important for you to learn your multiplication tables when you were younger. Some of you didn't, so now you're paying a price for that. But that's true about a lot of things. For example, we not too long ago we learned how to change these into improper fractions. You probably learned that last year. But if you haven't really learned it, you're gonna have a problem with this lesson. You see what I'm saying? You got to know how to do that. So you multiply this times the whole number, denominator times 1 is 18, and you add 2 and you get 20 over 3 times 3/5. Now, you can multiply it. What would you do first? Yes, cancel first. What can cancel? The 5 goes into 5 one time and into 24 times. And the 3 goes into 3 one time, and the 3 goes into 3 one time. So you get 4 over 1, which you can leave it like that, or you can change it to 4, either one. But you've got to change these to improper fractions. You don't have to cancel. 3 times 20 is 60. 3 times 5 is 15. That turns out to be 4 when you reduce it down, though. So it's better to cancel. It's a lot easier if you cancel first. All right, let's do one of these. Okay. So you want to guess what you have to do first? Make it improper. Yeah, first thing you're going to do in all these problems is first make sure they're all improper fractions. By the way, what if it's a whole number? Then you put it over 1. Okay, everybody clear about that? It's a whole number, put it over 1. Change it to improper fractions. 2 times 2 is 4, and 1 is 5. 5 over 2. Now don't change it yet. Just improper fractions. Now 3 times 3 is 9, and 1 is 10 over 3. Now I've got a division problem with 2 fractions. Yes, so this stays the same. 5 over 2. This changes to multiplication, and this changes to 3/10. Leave, change, flip. Leave this the same, change this, and flip it. Or, now hold on just 1 second. To divide by 10/3 is to multiply by the what? What do we call these numbers? Reciprocals. The reciprocal of 10/3. Now, guys, you need to know that word. Some of you on that last test, it asked you to write the reciprocal, and some of you couldn't do it because you haven't learned that word. But all you do is write it like a fraction and then flip it. So 10/3 flipped is 3/10. That's the reciprocal. Okay, now we're going to multiply, and you can cancel. Guys, listen to me. Listen to me. If there was a way to cancel up here, like you could say, well, 2 and 10 will cancel, won't they? No, because it's division. You can't cancel till it's multiplication. You with me? It's important. Don't try to cancel up here. You got to get it to multiplication first. Now I can cancel the 5 and the 10. 5 goes to 5 1 time, 5 goes to 10 2 times. And 3 times 1 is 3, and 2 times 2 is 4. Yeah. And again, I told you before the last test, but when you're doing stuff like this, make sure you got plenty of room so you can see all those little numbers. If you lose one of them, you'll miss the problem. Okay? Now all the rest of them are kind of the same thing. So that's all I'm going to do right now. But anytime you work on a problem and you get confused, get help from me or somebody, except on a test, and then you got to do it yourself. Okay? Now I want to talk a little bit about multiples and common multiples and least common multiples. I don't see that word there in right now, but that's what we're going to be looking for, which is how we find least common denominators when you're adding fractions. Okay, now watch this. Let's take the number 3 and 5. Multiples of 3. You know what I'm talking about? Yeah, 1 times 3 is 3. 2 times 3 is 6. 3 times 3 is 9. You're just going up by 3, right? 12, 15. Let's keep going. 18, 21, 24, 27, 30, 33. Let's just stop there. All right, multiples of 5. This is easy for you, isn't it? 10, 15, 20, 25, 30, 35, 40, 45. Let's just stop there. Now, we are often looking at two numbers and trying to find the multiples they have in common. So 6 is a multiple of 3, but it isn't a 5. 9 is a multiple of 3, but not 5. 12 is a multiple of 3, but not 5. 15? Aha. 15. Yeah, and you can go on up. 20 is a multiple of 5, but not 3. 3 won't go into 25, but 3 will go into 30. Now, guys, are you listening? You can keep going. I could write those numbers out. Anybody guess what the next one's going to be? 15, 30. What's the next one going to be? 39. Well, I mean the one that both of them will go into. Yeah, actually 45, and then 60. So you can go on forever. Next one will be 75. Next one will be 90. You can just keep going. But listen, usually what we're interested in is the smallest common multiple. We call it least common multiple. Sometimes you'll see the letters LCM, or when you're working with fractions, LCD, least common denominator, least common multiple. It's the smallest number that both of them will go into without a remainder. It's the smallest number that both of them are factors of. Okay? Does that make sense to everybody? Yeah. Listen, guys, somebody in the last period, the second period, I don't remember, I think it was on the stuff we just finished, but I did a problem and they didn't get it. And they said that. Said, I don't get it. And I just went over it again. I love that. I don't mind you saying, I'm not with you, Mr. Hall. It's okay. I'll slow down. I'll do it again. I will. So it's okay if you need to do something again. I'll be glad to. All right. So, oh, there's where it says least common. multiple right here. They did 4 and 6, but you can read that in your book. Now, there's something else they're showing you here that's kind of handy. This is not necessary. You don't have to do this, but it's kind of handy. Look at this. If 16 flavored icicles cost $4, what was the price for each flavored icicle? Yeah. If 16 were $4, you need to divide $4 by 16, right? Now, you know how to do that. You can divide 16 into $4 and get the right answer. But they're wanting you to notice something. When you write a division problem like a fraction like this, you might not have even thought about that. You might have just said, well, I'm going to divide like this. Well, that's fine. I'll give you the right answer. It's fine. But if you write it as a fraction, you might notice, hey, I can reduce that fraction, right? 2 goes into both those. And 2 still goes into both those. Now, can you divide a dollar by 4 in your head? What do you get? 25 cents. A quarter. A dollar divided into 4 parts is 4 quarters, right? 25 cents. So this is not necessarily easy to do in your head, but this is. And if you reduce it down, it'll sometimes make the problem easier. Now, do you have to reduce it down to do this? No, you don't have to. So if you don't notice it, don't worry about it. But if you notice it, it might make the problem a lot easier for you. That's all that's there for. If you can make it easier. Sometimes you can multiply both the top and bottom by something to make it easier. I'll show you an example of that in just a minute. All right, now let's do some problems here. Find the least common multiple of each pair of numbers, 8 and 10. Now, guys, let me tell you what I do most of the time. Stay with me now. Stay with me. Think. I could write out all the multiples of 8 and 10, but I'm not going to do that. I'm going to take the number 10. That's the biggest one. I'll take the biggest one, and I'll start looking at its multiples. 8 will not go into 10. The next multiple is 20. 8 will not go into 20. The next multiple is 30. 8 will not go into 30. I'm talking about without a remainder. You understand what I mean? It's not a factor, so I probably should be saying 8's not a factor of 10 or 20 or 30. How about 40? Yeah, 8's a factor of 40. 8 goes into 40 without a remainder. That's the least common multiple. Yes, sir. Okay. Okay. That's fine. That's fine. I usually pick the big one, but that's fine, Thomas. It works. It works. You can pick either one of them. Usually it's easier to pick the big one for most problems, but he had a good point there. That's good. Now, 4, 6, and 10. I'm going to use the 10 again. So will they go into 20? 4 will, but not 6. How about 30? 6 will, but 4 won't. How about 40? No. How about 50? Nope. How about 60? Yes, there it is. I finally found it by going up by 10. 4 goes to 60 and 6 goes to 60. You may have to divide it out to check it. Now, are you still with me? Everybody cool. Okay, now let me show you one more trick that will really help you, especially when the numbers get bigger. I want you to watch me here. I'm going to do the factor tree on each of those numbers. 4 is 2 times 2. You remember how to do this? Everybody know how to do factor trees now? 4 is 2 times 2. 6 is 2 times 3. 10 is 5 times 2, right? The least common multiple will have to have all these factors. It has to have 2 2's because the 4 has 2 2's. So I've got to have 2 times 2. There's another 2, but I've covered it here. It's got to have a 2 and a 3. So I got to put that 3 down here. Now it's got a 2 and a 3 for the 6. It's got to have a 5 and a 2. Well, I've already got the 2, but I need a 5. So it's got a 5 and a 2 here, 2 and a 3 here, and a 2 and 2 here. Okay, they're all there now. When you multiply those together, you know what you're going to get? You want to guess? 60. So you could, for example, say 2 times 5 is 10, 2 times 3 is 6, and 6 times 10 is 60. However, it's easy for you to multiply those together. So if you want to factor first, it makes it easy, especially if the numbers are big. I'm going to do another one like that. Got to have these two factors for these two 2's for the 4. Got to have a 2 and a 3 for the 6. You got to have a 2 and a 5 for the 10. And it's got all of them here. All right. Now, on the next problem, they actually give bigger numbers. Let's look at 30 and 75. 30 is 3 times 10, right? Which is 3 times 2 times 5. You with me? Everybody see my factor tree? Okay, yeah, that's good. 75, and you don't really have to do this that way. You can go up by multiples of 75, and this one works fairly easy that way. But I want you to watch it and make sure you understand what I'm doing. 75 is 3 times 25, and that's 3 times 5 times 5. Okay, so my multiple has to have a 3 in it. This has to have 1. There's 1 over here and 1 over here. It has to have a 2 in it. There's not a 2 over here, but it has to be here. And it has to have 2 5s in it. It can't just have 1 5. It's got to have 2 because the 75 has 2 5s in it. So that should be the least common multiple. 3 times 5 is 10. 3 times 5 is 15. 10 times 15 is 150. That one you could have found by just doubling that and getting 150 and realizing, oh, 3 goes into that. You might have noticed that. 30 goes into that. Okay. So this is a way, I think, that makes it easy when the numbers get very big. Yeah. All right. Now they're trying to get you on this last couple of problems to do the tricks. 7.5 divided by 1. Now listen, guys. 7.5 divided by 1.5. You can do that just like we did those problems a while ago. There's nothing wrong with that. It's perfectly fine. I'm not telling you have to learn this. It's just a little trick to help you make it a little easier sometimes. In other words, let's do this like we did a while ago. 2 times 7 is 14 and 1 is 15. Divided by 2 times 1 is 2 and 1 is 3. Oops, it has. 2 times 1 is 2 and 1 is 3 has. Now I've got to change it to multiplication, right? 2's cancel. 3 cancels with the 15. You get 5 over 1, which is 5. Okay? They're wanting you to notice that if you put 7.5 over 1.5, if you don't get this, don't sweat it. But sometimes you might say, hey, if I multiply that by 2, that whole top is 15. And if I multiply this by 2, that whole bottom, it's 3. And 15 divided by 3 is 5. So it's easier that way. If you notice that, it's okay. As long as you multiply the top and bottom by the same number, or divide the top and bottom by the same number. But you got to be careful that you do it right. You can't make a careless mistake there. So that's just something you can do if you want to, if it makes sense to you. Let's do 24,000 divided by 400. Yeah, yeah. You can say, well, I'm divide both sides by 100, and that gives me 240 divided by 4, and that's pretty easy, isn't it? 60, yeah. 4 goes to 24 6 times 60. Yeah. All right. And that last one over there, 140 divided by 5. Look at this. Here's a thought. You could do that. It wouldn't be too hard, but you could say, hey, if I multiply both top and bottom by 2, I'll get 280 divided by 10, and that's really easy. That's 28. So if you can get your 10 there, it makes it easy to do it in your head. So if you can notice that kind of stuff, it can really help you. Sometimes it makes a difference. But if you forget it or don't notice it, it's not a deal. Just go ahead and work it the old-fashioned way. All right. You remember what average is, right? How do you find an average? Remember, there are 2 steps. What do you have to do?
Add everything and divide it.
Add everything and then divide it by the number of things, the number of items. That's right. All right. So that's a 2-step problem. You got to add everything first, then you got to divide. So on this section, they're just asking you to do a few 2-step problems. Let's look at a few of them. Jody went to the store with $20 and returned home with $5.36. If all she bought was 3 bags of dog food, how much did she pay for each bag? Yeah. First thing you have to know is how much she spent on dog food. She went with $20. She came home with $5.36. So to find out how much she actually spent, you got to subtract what she came home with. Yeah, change this to 1990 right? Borrow the 1 here and 1 here. 1990 10 minus 6 is 4. 9 minus 6 is 9 minus 3 is 6. 9 minus 5 is 4. 1464. Is that right? Now what do you do? Divide that by 3. The 3 bags. She spent $14. That's how much she spent. She came home with $5.36, so she spent $14.64, and that's on 3 bags. So how much per bag? We just divide it. 3 goes to 14. 4 times 12, 26. 3 goes to 26. 8 times. 8 times 3 is 24. And there's an 8 again. 3 times 8 is 24. $4.88. Two-step problem. That's the point. 3/8 of the 32 children in the club were girls. How many were boys? All right. If you want to, you can draw that diagram. You remember you put the boxes, an 8. You can do it that way. That's fine. I don't care. But this time I'm going to do it this way. 3/8 times 32. And I'm going to write it over 1 so it looks like a fraction. 8 goes into 8 1 time, 32 4 times. 3 times 4 is 12. What did I just find? What is 12? Really, Sophia?
Number of number of
With me? Well, what is it? It's the number of girls. 3/8 of the 30 children were girls. 3/8 were girls. 3/8 of 32 is 12, so there are 12 girls. Now, how are you going to find how many boys? Well, the easiest way is probably you could do 5/8. That's true. It works. Or you could subtract 12 from 32, couldn't you? Yeah, that's what's left. Okay. To do the mean, you add these up 1, 2, 3, 4, 5, and divide by 1, 2, 3, 4, 5, 6. Divide by 6. Add them up. Whatever you get, divide by 6. You understand mean and average are the same thing, right? Exactly the same thing. When it says mean or when it says average, you do it the same way. All right. Yep, that's right. Oh, okay. Yep, yep. Where'd you see that? Oh, okay. You're looking at this one. I was looking at that one. Okay, yeah. But the number halfway between. If it's just two numbers, the average and mean will be the same. So the average and mean and median will be the same. Okay. Let me look at something else here. Let's see. I'm going to do F, and then we'll probably stop. Willis has taken 8 tests. His lowest score was 80. His high score was 95, which of the following could be his average. All right, so the lowest is 80, the highest is 95, and they've got 80, 84, 95, and 96. Yeah, yeah, yeah. That's right. Very good. Very good thinking. Can't be 96. That's higher than any mate he makes. That's silly. Can't be 95 because he made an 80. That's going to pull that down. Can't be an 80 because he made a 95. That's going to pull that up. So it could be an 84 depending on what the other grades were. Yeah, that's very good thinking. Very good thinking. Okay. All right. All right. I'll stop there and pick it up there next time. It's going to be one of those weird things because of Thanksgiving. We will finish our study next week, and then you won't have the test till after Thanksgiving. Okay. Okay. Anything else? Father, thank you for these kids. Thank you for the way they worked hard to try to learn this today and participated. Thank you for the way they tried to think about it and try to figure it out. Lord, I pray you'd help them to realize that's an important part of life is making their brain work as hard as they can to learn as much as they can. And Lord, that's true for the kids who are really, really smart, but it's also true for the kids that have a lot of trouble with math. So please help them all to realize that they need to give it their best shot. They need to work hard. They need to study. They need to retake tests when necessary. They need to learn these things, get somebody to help them, but to learn it. Or please help them to take it seriously. Thank you for getting us through this week. We thank you for the rest of the week. Help us to bless you and make good decisions this weekend. Bring us back safely on Tuesday, please. Help us to bring you lots of glory, to be a blessing to each other, to other teachers, to family members, whoever you bring into our lives these next few days. We want to represent you well. So please use us any way you choose for your glory. In Jesus' name, amen.